Hi friends, welcome to SAIJAYANI. So next unit is industrial chemistry for DCET point of view. So it is for 8 marks. Industrial chemistry unit number 6. So in this chapter, industrial chemistry, very first concept is electrolysis. So what is electrolysis? So before going to electrolysis, we have to know what are conductors. So first concept is conductors. So what are conductors? So conductors are the substances which allow to flow of electric charges from one point to another point, or which allows to flow electricity. So conductors are the substances which allow electric charge or electricity. So conductors are the substances which allow electric charges or electricity. So example aluminum, copper, brass, steel. So these are the substances which are allowed to flow electricity, which helps to flow of electric charges from one point to another point. So aluminum, copper, brass, steel are the conductors which allow to the flow of current. So conductors are the substances which allow to flow of electric charge. Electric charge ಅನ್ನು ತನ್ನ ಮೂಲಕ ಫ್ಲೋ ಆಗಕ್ಕೆ ಅಲೋ ಮಾಡ್ತಿದ್ರೆ ಆ ಸಬ್ಸ್ಟೆನ್ಸ್ ಗಳಿಗೆ ನಾವು ಕಂಡಕ್ಟರ್ ಅಂತ ಕರಿತೀವಿ. ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಯೂಮಿನಿಯಂ, ಕಾಪರ್, ಬ್ರಾಸ್. ಸೊ ಈ ಮೆಟಲ್ಗಳು ಎಲೆಕ್ಟ್ರಿಸಿಟಿನ ಫ್ಲೋ ಆಗಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡ್ತವೆ, ಅಲೋ ಮಾಡುತ್ತೆ. ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್ ಅನ್ನು ಒಂದು ಪಾಯಿಂಟ್ ಇಂದ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ಗೆ ಫ್ಲೋ ಆಗಕ್ಕೆ ಅಲೋ ಮಾಡುತ್ತೆ. ಸೊ ದೀಸ್ ಆರ್ ದ ಕಂಡಕ್ಟರ್ಸ್. ಅದಕ್ಕೆ ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ವೈರ್ಸ್ ಗಳನ್ನು ನಾವು ಅಲ್ಯೂಮಿನಿಯಂ ಇಂದ, ಕಾಪರ್ ಇಂದ ಮಾಡಿರ್ತೀವಿ, because they are good conductor of electricity. So next, opposite to conductors, conductor ಗೆ opposite, so insulator. So what are insulators? Insulators are the substances which do not allow to flow of electric charge from one point to another point, or these are the substances which do not allow flow of electricity within them. So substances which do not allow flow of electric charge or electricity are called insulator. So insulator ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಸಿಟಿನ ಅಥವಾ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್ ಅನ್ನು ಫ್ಲೋ ಆಗೋದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು. ಸೊ ವಿತಿನ್ ದಟ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್ ಒಂದು ಪಾಯಿಂಟ್ ಇಂದ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ಗೆ ಹೋಗದೆ ಇರೋ ನಾವು ರಿಸ್ಟ್ರಿಕ್ಟ್ ಮಾಡ್ತೇವೆ. ಆ ಸಬ್ಸ್ಟೆನ್ಸ್ ಗಳಿಗೆ ನಾವು ಇನ್ಸುಲೇಟರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಎಕ್ಸಾಂಪಲ್ ರಬ್ಬರ್, ವುಡ್, ಸ್ಟೋನ್, ಎಕ್ಸೆಟ್ರಾ. ಸೊ ಈ ಸಬ್ಸ್ಟೆನ್ಸ್ಗಳು ಎಲೆಕ್ಟ್ರಿಸಿಟಿನ ಕಂಡಕ್ಟ್ ಮಾಡಲ್ಲ, ಎಲೆಕ್ಟ್ರಿಸಿಟಿನ ಒಂದು ಪಾಯಿಂಟ್ ಇಂದ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ಗೆ ಅವು ಟ್ರಾನ್ಸ್ಮಿಟ್ ಮಾಡಲ್ಲ. ಸೊ ಅವು ರೆಸಿಸ್ಟ್ ಮಾಡ್ತವೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್ ಅನ್ನ ಫ್ಲೋ ಆಗೋಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡೋದಿಲ್ಲ. ಸೊ ಈ ತರದ ಸಬ್ಸ್ಟೆನ್ಸ್ಗಳಿಗೆ ನಾವು ಇನ್ಸುಲೇಟರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಕಂಡಕ್ಟರ್ಸ್ ಆರ್ ದ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ವಿಚ್ ಅಲೋ ಟು ಫ್ಲೋ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್, and insulator are the substances which do not allow flow of electric charge within them. So next, in conductor we have two types. There are two types in conductors. Types of conductor. So there are mainly two types of conductor. First one, metallic conductors. Second one, electrolyte conductors, or electrolytes. So there are two types of conductors, metallic conductor and electrolyte conductors are electrolytes. So what are metallic conductors? So metallic conductors are so these are the conductors which allow flow of electricity or flow of electric charge within them, and they do not undergo any decomposition. They do not undergo any decomposition. And they remains in solid state. So electricity flow ಕ್ಕೆ help ಮಾಡುತ್ತೆ, and they do not undergo any decomposition. Decomposition means decay ಅಥವಾ ನಶಿಸಿ ಹೋಗೋದು ಅಥವಾ ಉಳಿಯೋದು. ಆ ತರ ಏನು ಇಲ್ಲಿ ಮಟೀರಿಯಲ್ decay ಆಗೋದಿಲ್ಲ. Without undergoing decomposition, it allows to flow of electricity and which remains in solid state only. ಆ ತರದ ಕಂಡಕ್ಟರ್ ಗಳಿಗೆ ನಾವು ಮೆಟಾಲಿಕ್ ಕಂಡಕ್ಟರ್ ಅಂತ ಕರೀತೀವಿ. So metallic conductors are the substances which allow to flow of electric charge without any decomposition, and they are always remains in solid state. Example for metallic conductor, again give examples of them: aluminum, copper, brass, steel. So these are the metallic conductors. Type conductor alle first type metallic conductor ಗೆ these are the examples. So metallic conductors aluminum, copper, brass, steel. So ಇವುಗಳಿಗೆ ನಾವು ಕರೆಂಟ್ ಪಾಸ್ ಮಾಡಿದಾಗ ಇವೇನು ತನ್ನ ಸ್ಟೇಟ್ ಅನ್ನು ಚೇಂಜ್ ಮಾಡಲ್ಲ, ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಮತ್ತು ಅದೇನು ಡಿಕೆ ಆಗಲ್ಲ, ಕೊಳೆಯಕ್ಕೆ ಹೋಗಲ್ಲ ಅಥವಾ ಹಾಳಾಗಕ್ಕೆ ಹೋಗಲ್ಲ, ಸೇಮ್ ಅದೇ ಸ್ಟೇಟ್ ಅಲ್ಲೇ ಇರುತ್ತೆ. ಸೊ ಈ ತರದ ಕಂಡಕ್ಟರ್ಗಳಿಗೆ ನಾವು ಮೆಟಾಲಿಕ್ ಕಂಡಕ್ಟರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಮೆಟಾಲಿಕ್ ಕಂಡಕ್ಟರ್ಸ್ ಆರ್ ದ ಕಂಡಕ್ಟರ್ಸ್ ವಿಚ್ ಅಲೋ flow of electric charge or electricity without undergoing any decomposition, and they remains in solid state only. Next, what about electrolyte conductors or electrolytes? These are the conductors which allow flow of electric charge in liquid condition or in solution state. Liquid condition or solution states. So you ಕೂಡ conductors, but they are in liquid state. So liquid state ಅಲ್ಲಿ ಇರುತ್ತೆ, and they undergoes decomposition. So ಇವು decomposition ಗೆ ಒಳಪಡುತ್ತವೆ. Decomposition means decay, ಹಾಳಾಗ್ತವೆ. So while conducting electric charge or electricity, they undergo decomposition. So ಆ ತರದ ಕಂಡಕ್ಟರ್ಗಳಿಗೆ ನಾವು electrolyte conductors or electrolytes ಅಂತ ಕರಿತೀವಿ. So example HCl, hydrochloric acid. So HCl ಅನ್ನು ನಾವು electrolyte ಅಂತ ಕರೀಬಹುದು. So which conduct electricity in liquid state and undergoes decomposition. So ಯಾವ ಸಬ್ಸ್ಟೆನ್ಸ್ ಕರೆಂಟ್ ಅನ್ನು ಕಂಡಕ್ಟ್ ಮಾಡಿ ಮತ್ತೆ ಡಿಕಂಪೋಸಿಷನ್ ಆಗ್ತಾ ಇದ್ರೆ ಆ ತರದ ಕಂಡಕ್ಟರ್ಗಳಿಗೆ ನಾವು ಎಲೆಕ್ಟ್ರೋಲೈಟಿಕ್ ಕಂಡಕ್ಟರ್ಸ್ ಆರ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಎಕ್ಸಾಂಪಲ್ HCl. So next, electrolytes. So as I said, electrolytes are the substances which allows to flow of electric charge or electricity in solution state only, and while passing electric charge or electricity, they undergo decomposition. So electrolytes are the substances which allow flow of electric charge in solution state and undergoes decomposition. In electrolytes, there are mainly two types: strong electrolytes and weak electrolytes. So what is strong electrolyte? So a strong electrolyte in which while passing current, complete ionization takes place. So a strong electrolyte is a substance in which electric charge or flow while the substance decomposes and ionization takes completely. So what is ionization? The process of splitting of ions of a solution is known as ionization. So ಯಾವ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಪಾಸ್ ಆಗಬೇಕಾದ್ರೆ ಅಯೋನೈಸೇಷನ್ ಕಂಪ್ಲೀಟ್ ಆಯಿತು ಅಂದ್ರೆ ಆ ಸೊಲ್ಯೂಷನ್ ಆ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಗಳಿಗೆ ನೀವು ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಇನ್ ವಿಚ್ ionization is completed ಸೊ ಕಂಪ್ಲೀಟ್ ಅಯನೈಸೇಷನ್ ಆಯಿತು ಅಂದರೆ ಆ ಥರದ ಸಬ್ಸ್ಟೆನ್ಸ್ಗಳಿಗೆ ನಾವು ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ NaCl, sodium hydroxide, HCl, hydrogen chloride, NaOH, sodium hydroxide, KOH, potassium hydroxide. So these are the strong electrolytes. So you strong electrolyte. So ಇದಕ್ಕೆ ನಾವು ಏನಾದರೂ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಅಥವಾ ಕರೆಂಟ್ ಅನ್ನು ಪಾಸ್ ಮಾಡಿದ್ರೆ ಅಯನೈಸೇಷನ್ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ and they are good conductor of electricity. Good conductor of electricity. ಅಥವಾ conduction of electricity is very higher in case of strong electrolyte. So strong electrolyte ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಯನೈಸೇಷನ್ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ and they are good conductor of electricity, or conduction of electricity is good in case of strong electrolytes. So then what are weak electrolytes? So weak electrolytes are the substances which do not conduct any electricity. So electricity na conduct ಮಾಡಲ್ಲ and there is no complete ionization. Ionization really complete ಇರಲ್ಲ. So no complete ionization. No complete ionization and they are not good conductor of electricity. So compared to strong electrolyte compare ಮಾಡಿದ್ರೆ so weak electrolytes are not strong conductor of electricity. So example for weak electrolytes: acetic acid, benzoic acid, benzoic acid and aluminum hydroxide. So these are the example for weak electrolytes. And example for strong electrolytes: NaCl, HCl, NaOH, KOH. So these are the example for strong electrolytes. And the difference between strong electrolyte and weak electrolyte is the complete ionization takes place. Here no complete ionization and they are good conductor of electricity and they are not good conductor of electricity. So next concept, Faraday's first law of electrolysis. So Faraday's first law of electrolysis states that the mass of substance liberated during the electrolysis is directly proportional to the quantity of current passing. So Faraday's first law states that the mass of substance liberated during electrolysis is directly proportional to quantity of electricity passed. So Faraday's first law states that the mass of substance liberated during the electrolysis is directly proportional to the quantity of electricity passed. So this is the statement of first law of Faraday's first law of electrolysis. So Faraday's first law of electrolysis ಏನು ಸ್ಟೇಟ್ ಮಾಡುತ್ತೆ? mass of substance. So electrolysis ನಡೀತಿರಬೇಕಾದ್ರೆ ಏನು amount of substance ಬರುತ್ತಲ್ಲ is during the electrolysis is directly proportional to quantity of electricity passed. So electrolysis ಆಗಬೇಕಾದ್ರೆ ನಮಗೆ ಏನು ಮಾಸ್ ಸಿಗುತ್ತಲ್ಲ ಯಾವುದಾದ್ರೂ ಮಟೀರಿಯಲ್ದು ಅದು ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ದಿ ಕ್ವಾಂಟಿಟಿ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಪಾಸ್. ಸೊ ಎಷ್ಟು ನಾವು ಕರೆಂಟ್ ಕೊಡ್ತೀವಿ ಅಷ್ಟೇ ಮಾಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ ಅಂತ ಸ್ಟೇಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಬೈ ದಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ವಿ ಕ್ಯಾನ್ ರೈಟ್ ದಟ್ ದ ಮಾಸ್ ಆಫ್ ಎ ಸಬ್ಸ್ಟೆನ್ಸ್ liberated during the electrolysis is directly proportional to the quantity of electricity pass. So electricity means electrical charge. So Q andre it's an electrical charge. Mass of a substance is directly proportional to the electric charge. So where Q is electric charge. So the unit of electric charge is coulomb. Electric charge coulomb. So mass is directly proportional to the quantity of electricity passed. So ಇದಕ್ಕೆ directly proportional ಅಥವಾ inversely proportional ಅಂತ ಹೇಳಿದಾಗ ನಮಗೆ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಸಿಗುತ್ತೆ. So m is equal to z into q. So where z is electrochemical equivalent of substance. So z is a ECE, electrochemical equivalent. So z ಅಂದ್ರೆ ಏನು? Electrochemical equivalent of substance. Electrochemical equivalent of substance. So mass is equal to z into q. So z ಅಂದ್ರೆ ಏನು? It is the electrochemical equivalent of that substance. Q ಅಂದ್ರೆ it's electricity passed. So ಹೇಗೆ ಬರೀಬಹುದು? But q ಅಂದ್ರೆ what is q? Q is equal to, so electricity ಅಥವಾ electric charge is equal to, it is the product of current and time. So I into t, where I ಅಂದ್ರೆ ಏನು? Current. So where I is current in ampere and t is the time in second. So m is equal to z, q place ಅಲ್ಲಿ ನಾನು I into t ಬರೀತೀನಿ. So m is equal to the product of z I t. So where z is the electrochemical equivalent of substance, I ಅಂದ್ರೆ current in ampere, t is the time duration at which we pass the current, so time in second. So the product of electrochemical equivalent, current and time gives the mass liberated during the electrolysis. So by this equation we can write that z is equal to m divided by I into t. So what is the formula to find the chemical equivalent of a substance is given by z is equal to m divided by I and t. So definition ಹೇಗೆ ಹೇಳ್ಬೋದು? So electrochemical equivalent is defined as the ratio of mass of a substance liberated during the electrolysis to the ratio of product of current and time. So where m is a mass, I is the current, t is the time. So the ratio of mass to the product of current and time is this gives the value of z. Z means electrochemical equivalent. It is defined as the ratio of mass liberated during the electrolysis to the product of current and time. Electrolysis states that the mass of different substances deposited electrode when the same quantity of electricity is passed is directly proportional to the chemical equivalent of that substances. So mass of different substance, mass of different substance deposited at electrode when the same quantity of electricity when the same quantity of electricity is passed is directly proportional to equivalent weight of the substance. So Faraday's second law of electrolysis states that mass of different substances deposited at electrode when the same quantity of electricity is passed is directly proportional to the equivalent weight of that substances. So in general, we can write that mass is directly proportional to E. So where M is mass of substance and E is equivalent weight of substance. So M is directly proportional to E, where M is a mass of substance, E is the equivalent weight of substance. Consider there are three masses, M1, M2, M3, and correspond and their equivalent weight as E1, E2 and E3. So consider three different materials, three different substances, M1, M2, M3, and their equivalent weight E1, E2, E3. Then from Faraday's second law of electrolysis, we can write that M1 by E1 is equal to M2 by E2 is equal to M3 by E3. So this is the mathematical relation of Faraday's second law of electrolysis. So Faraday's second law of electrolysis states that mass of different substances such as M1, M2, M3 deposited at electrode when the same quantity of current I1 is equal to I2 is equal to I3. So when current remains same for all three different substances, then the mass deposited at electrode is directly proportional to the equivalent weight of the substances. So mathematically we can write that M is directly proportional to E. So where M is the mass liberated and capital E is the equivalent weight of substances. If I consider there are three masses with three equivalent weight, we can write that M1 by E1 is equal to M2 by E2 is equal to M3 by E3. So next problems on Faraday's law of electrolysis. So first question, what mass of copper is deposited on the cathode of a copper voltmeter by a current 2 ampere in 30 minutes? ECE of copper 0.003 gram per coulomb. So he has given, we have to find mass question mark deposited cathode at copper voltmeter by current I. He has given I value 2 ampere and time he has given 30 minutes and ECE of copper is given 0.03 gram per coulomb. So time is in 30 minutes, we have to convert in second. So 30 into 60, 1800 second. 1800 second. So from Faraday's first law of electrolysis, we have formula M is equal to Z I and T. M is equal to Z into I into T, where Z is the ECE, electrochemical equivalent of copper, that is 0.003 gram per coulomb. So we have to use these values, I value, Z value, T value in this equation. So M is equal to Z is 0.003, I value is 2 ampere and T in second 1800. So the product 0.03 into 0.003 into 2 into 1800. So 0.003 into 2 ampere into 1800. is the answer. So a mass of 10.8 gram liberated when 2 ampere current for 30 minutes of chemical equivalent 0.03 gram per coulomb is supplied. This is the solution for this problem. So next question, Faraday's first law of electrolysis is represented mathematically as dash. So this question is asked in 2018 DCET question paper. So mathematical relation of Faraday's first law of electrolysis. Option 1, M is equal to Z into Q. Option 2, Z is equal to M into Q. Option 3, Q is equal to M into Z. Option 4, M is equal to Z by Q. So we know that from Faraday's first law, mass is directly proportional to the quantity of electricity passed. So M is equal to, we can write that Z is equal to I into T, or M is equal to Z into Q. So where Q means it is the product of I into T. So in place of I into T, I have write Q. So M is equal to Z into Q. So option A, M is equal to Z into Q is the right answer. So next question, when same current is passed through two cells, one containing copper sulfate solution and other contains silver nitrate solution, 1.25 gram of copper and 4.25 gram of silver are deposited. The equivalent weight of silver is 107.78. Find the equivalent weight of copper. So he has given two solutions, copper sulfate solution and silver nitrate solution. So there are two solutions, copper sulfate. I will take this solution as M1. Corresponding values I will take 1. So this copper sulfate solution is first solution, and silver nitrate as solution number 2. So 1.25 gram of copper. So copper, he has given the mass of copper. So since copper sulfate solution is indicated by 1, I will write mass of copper as M1, 1.25 gram. Next, 4.25 gram of silver. So M2 is 4.25 gram of silver. So mass of copper is 1.25 gram, mass of silver is 4.25 gram. The equivalent weight of silver. So he has given the equivalent weight of silver. Equivalent weight means capital E2. E2 is equal to 107.78. Then find equivalent weight of copper. So copper question mark, E1 is question mark. From Faraday's second law, we have a mathematical relation M1 by E1 is equal to M2 by E2. So we have to find E1. Then so M1 is equal to E1 by E2. So I will cross multiply. This M1 into E2 is equal to E1 into M2. So we have to find E1. So E1 becomes, E1 is equal to M1 E2 divided by M1 E2 divided by M2. So where is M1 value? We have M1 is equal to 1.25 gram and M2 value we have 4.25, and so E2 we have E2 value. So E2 value is 107.78. So then E1 becomes 1.25 divided by 4.25 into 107.78. 0.78. So we will get 31.7 is the right answer. So this is the solution for this question. So the equivalent weight of copper is 31.7.